Welcome back, everybody. This is the second video lecture that is being presented for the business calculus class. Today, we are going to be doing a little bit of algebra review. This is still stuff that you should already know, but I want to make sure to go over it. That way, in case you're having a little bit of an issue with it, you can see what's happening here. Today, we're going to be talking about interval notation, exponents, radicals, and how to solve equations. First thing we'll talk about is interval notation. You should have already heard about this. This is when you're talking about intervals of numbers, starting at one and going to another number. There's four possibilities that you can have. You can have parentheses, parentheses, bracket, bracket, parentheses, bracket, and bracket, parentheses. Doesn't seem much of a difference, but you use the parentheses when the end value is not included. So, in a situation where you want to go from 5 to 10 and any number in between, but you don't want 5, you would want parentheses on the 5, and then you'd go to 10 and have a bracket on the 10 if it's allowed. Now, as I just said, brackets is the opposite of parentheses, which means you are allowed to have them. So if you can go up to 10, including 10, put a bracket. One part about this to always remember is you can never get to infinity, so infinity should always have a parentheses because it cannot be included. Now, if you have multiple intervals, so say you're allowed to go from 2 to 4 or 6 to 8, you want to put a union, which is denoted by a big U, between them, which means you can go from one interval or the other interval. Again, either is allowed. Now here's a couple examples. If we have parentheses 2, 3 bracket, 2 is not included, but 3 is. We also have 2.1, 2.0000001, so on. You can put as many zeros there as you want. Any number, as long as it is bigger than 2, is included, but 2 itself is not. Now look at exponents. We have a few different rules about them that we need to remember. First of all, the basic definition of an exponent, so x to the third, you can view it as 1 times x times x times x. There's an advantage of having it set up like this, because it allows if x to the 0 would be 1 multiplied by no x's, so it would just be 1. Now here are a list of a few simple exponent rules that you need to remember. If the base is the same and they're getting multiplied, you can just add exponents. If the base is the same and you're dividing, you subtract exponents. If you have a base to an exponent, all raised to another exponent, you multiply the exponents. If you have two things multiplied together inside parentheses getting raised to an exponent, the exponent goes onto both. Same thing happens if you have a fraction where the entire fraction is getting raised to an exponent. If you have a negative exponent, that flips to the denominator, but it will be the denominator of everything that is getting multiplied by. Now, radicals. If you have n radical x, that means the nth root. Often you would have seen the squared root, nth root, it could be third root, so on. Radical is just asking what number multiplied together a certain number of times equals x. So squared root means that number multiplied by itself twice, so it comes out to the x. A cube root would be multiplied by itself and then by itself again, so it would be multiplied 3 times to get x again. Here are a few basic radical rules. You can take a radical and turn it into an exponent. This is something that makes it very easy later on when dealing with some of the calculus aspects of this class to solve more complicated equations. The same way as it worked for exponents on things getting multiplied, works for the radicals, and so on. Now, there are many ways to solve equations. In this class, you can use just straight algebraic ways. You can use your calculator, but you need to explain what you're doing on your calculator. And you can use guess and check. This one, I expect you to give logic of why you are guessing certain things. So if you guess 2 and it happens to be the correct answer, explain why you guessed 2. And one last thing I want to talk about quickly is significant digits. When you're dealing with significant digits, you don't want to write down a 15-digit number always for every single step. That gets very complicated. But you do want to keep the significant amount. So significant digits work that you want to keep the fewest number of digits based off the initial problem. So a couple of quick examples. For this problem, we have 2.41 multiplied by 0.15. Zeros, in general, are not classified as significant digits unless they are in between other numbers. So if it was 0.1, then you'd have 3 significant digits. But since you do not, the 0.15 just has 2 significant digits, whereas the 2.41 has 3. Since one of them has 2, one has 3, the ending answer should only need 2. All right.